Hello students, we will now move on to the last page replacement technique, which is least recently used, in short LRU. So far you have seen the purpose for page replacement and the techniques under it, that is FIFO and optimal page replacement. Okay, so least recently used is a different version of FIFO. Okay, let us take an example to understand LRU. Okay, now here, the same reference string is taken like in the previous two examples, and the number of frame size is 3. Okay, yeah. Now, in LRU, you will have to replace the page which is least recently used. So, there is one difference between FIFO and LRU. In FIFO, the pages that were a hit were not considered. Okay, in LRU, you will have to consider the page hit pages. Okay, now we will start with it. 7. It is not in the main memory initially, so it's a page fault, and 7 is included because it has got a free frame. 0 is not in the main memory, so it's a page fault, but it can now sit in the main memory because it has a free frame. 1 is not in the main memory, so it's a page fault, and 1 is sitting in the main memory because it has a free frame. Now coming to 2. Yeah, so as per LRU, we have to replace the page that is least recently used. So 1, no. 0, no. 7 is least recently used. So in the place of 7, you'll have to write 2. So far so good, because the same thing happened in FIFO also. Now coming to 0. 0 is already in the main memory, so it's a page hit. So this also was the same in FIFO. Okay. Now coming to 3. This point, the replacements in LRU changes from FIFO. Now, as I said, in FIFO, you did not consider the page hit, right? You did not consider the page hit. Sorry, this is a page hit for 0 and this is a page fault. You did not consider the page hit, okay, for finding the replacement. But in LRU, you need to consider this. Now, this is the only difference between LRU and FIFO, okay? So now, so we need to accommodate 3, but which one to replace? 0, no, because it is recently used, right? What about 2? No. Yes, 1 can be replaced. So 1 is replaced with 3. Yeah, and it was initially a page fault because we did not find 3 over here. What about 0? It's a hit because, why is it a hit? Because 0 is in the main memory. Okay, so it's a hit. Clear? Now what about 4? 4 is not in the main memory, so that's a page fault. But which one should you replace? Can you replace 0? No, it is least recently used. Can you replace 3? No. What about 2? 2 is the least recently used. So replace 2 with 4. Now coming to 2. Is 2 in the main memory? No, it's a page fault. But which one should you replace? Can you replace with 4? No. Can you replace with 0? No. 3 is the least recently used. So in the place of 3, you put 2. Coming to the next page, 3. 3 is not in the main memory. So it is a page fault. So which one should you replace? Can you replace 2? No. Can you replace 4? No. You should be replacing 0. Okay. So 0 is replaced with 3. Coming to 0. Is 0 in the main memory? No. So it's a page fault. Now which one should you replace? Can you replace with 3? No, because it is used recently, right? 2? No. What about 4? Yes, because it is least recently used. So 4 is replaced with 0. What about the next page, 3? It is already in the main memory, so it's a hit. What about 2? 2 is also in the main memory, so it's a hit. What about 1? Is it in the main memory? No. So it's a page fault. So which one should you replace? 2? No. 3? No. 0? Yes. Okay, so 1 is written here. What about 2? 2 is already in the main memory, so it's a hit. What about 0? It's not in the main memory, so that's a page fault, right? So which one should you replace? 2? No. 1? No. 3 is least recently used. So in the place of 3, you put 0. What about the next page? 1. It is in the main memory, so it's a hit. What about 7? 7 is not in the main memory, so which one should you replace? 1? No. 0? No. 2. Yeah, 2 should be replaced with 7. Okay, and it's a page fault because 7 was not found in the main memory. What about 0? It is in the main memory. 1, it is in the main memory. So for 0 and H, it is in the main memory. So it's a page hit. So if you try finding, so we have 1, 2, 3. So this is 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 page faults. Okay. So this is how you find out the number of page hits and the number of page faults. So if you find out among the three, you will find that optimal is the best one, then it is LRU, and then it is FIFO. So it is very simple. You will be given a reference string. You just need to remember that in FIFO, we will replace the process or the page. We replace the page that has come first, and we do not consider the page hits. Okay. In optimal, you will have to replace the page that will not be used in the near future. That is, you need to go to the right. This is, you need to go to the left. Now coming to LRU, LRU is a different version of FIFO. That is, you will need to scan to the left, but then here you will need to consider the page hit pages also. That's it. So you will be given a reference string, you will be given the frame size, you will have to find out the number of page faults for each of these page replacement algorithms. I hope this is clear to you guys. Yeah, it is very easy. Yeah, but then you need to practice with a lot of problems. Fine. So we will be shortly giving you an assignment on these problems. Okay. Thank you.